Now we are going to solve a bunch of solving triangles type problems. Solving triangles means when you're given a triangle and you're given sum of the length and the angles, you have to find out all the remaining sides and angles. Now, before I go on, I should start with a naming convention. The naming convention is that the vertices, these corners, are named as capital A, B, and C. And the naming convention for the sides of the triangle is that use lowercase, but the same letter as the opposing angle. So, see, this side is opposed to capital A, so you put lowercase a. This side is opposed to C, so you put lowercase c. This side is opposed to capital B, so you put lowercase b. So that's the naming convention. Now, with this naming convention, there are a few things, actually 3 formulas that you have to know. The first is something that you learn, which is very trivial, right? The 3 angles, A plus B plus C, well, I should use angle, sorry. The angle A, by the way, another convention is that we're gonna, instead of using this angle A, we're just gonna say A, okay? So, angle A plus angle B plus angle C is 180 degrees. That's something that probably everyone knows, right? The internal angle of a triangle is 180. Now, what many people will not be so familiar with is the 2 laws. The first thing is the Sine Law, which is that A over sine A is equal to B over sine B, which is equal to C over sine C. Okay. And then the next thing is Cosine Law, which is C squared is equal to A squared plus B squared minus 2AB cosine angle C. Right, the sine law is rather easy to remember. It's very symmetric, right? Cosine law looks a little more complicated than the sine law, so many people have trouble remembering this. Well, think of it this way. Cosine law is an extension of the Pythagorean theorem, which is c squared equals a squared plus b squared. You knew this, right? And that happens when cosine, the c is 90 degrees. So it's a property of the cosine that cosine of 90 degrees is 0. Okay, you can calculate this using a calculator. If you put cosine of 90 degrees, you're going to get 0. Okay. So you get c squared equals to a squared plus b squared, and if you have 90 degrees, it's just the Pythagorean theorem. But if it's not 90 degrees, you end up with some weird thing that fixes some incoherences because it's not 90 degrees. So this ends up working. This is called the cosine law. Now, however, if you know just one of the cosine law, then you can shift letters around like that to obtain 2 other laws, right? So if I apply this to this, C becomes A becomes B becomes C, and then minus 2, A becomes B becomes C, and then cosine, and then C becomes A. Okay. And thirdly, if you apply this yet again, A becomes B becomes C becomes A, B becomes C, and then C becomes A, and then A goes to B. So there are these three laws. That's called the cosine law. But among these three, you really need to remember one of them, and then the other ones you can obtain by just rotating around like this. Okay. So when do you use it? Well, we're going to be using this frequently, and it's very easy. It's just the only problem is when do you get to use sine law and when do you get to use cosine law? Well, the short answer is this. You use the sine law if you have just one side. Okay? And you use the cosine law if you're given 2 or 3 sides are known. Oh, so I should probably be more descriptive here. If just one side is known, you want to use the sine law, and if 2 or 3 sides are known, then use the cosine law. And that's it. You just need to know these three, and you're set to solve many of the problems that you're about to solve. Okay, and you just solve problems, and you can learn as you do this. Okay, so without further ado, let's try to do the first question. All right, so you have one side known, right? And 2 sides are unknown. These angles are not known either. Well, this angle should be known because first A plus B is 32, and then C is 90, and that has to equal to 180 degrees. So you get, if you subtract 90, that's 180 minus 90 is 90, and then subtract 32, and that gives you angle A equals to 58 degrees. Okay, so see, solving a triangle means you find all the angles, and since this is 90, that's 32, we already knew that, but this we did not know, and we found out that that is 58 degrees. So that's good, right? Now you still have to know 2 of the lengths, and because only one side is given, we're going to use the sine law. So let's try to remember the sine law. It's very symmetric. It's easy to remember. A over, it's sine law, so what can it be? It's a sine of something, right? And you just pair it with the length and the angle. That's all you do. And by the way, some books don't have it this way. They have this flipped, which is the same thing. This is equivalent to, say, if you flip everything, if you take the reciprocal of everything, it also means sine of A over A, the sine of B over B, and then sine of C over C. So this is also another thing that's possible. Okay, but I'll stick with this because that's less confusing. But either way, if you can remember any one of them, you'll be able to solve these problems. Okay, so these two are the same thing. All right, so what are we trying to do here? A over angle A, so A over sine of angle A, and we know that that's angle 58, equals to B over angle 90, sine 90 degrees, equals to C, which is 8 over angle 32, sine of 32 degrees. Okay, so that's what, I just plugged in all the angles that I know, and this is what I got, okay? And the goal is to find out what A is, what B is. That's what you need to know. So let's first try to figure out what this is, right? What is 8 divided by sine 32 degrees? Well, then I will need my calculator. And the thing is, your calculator usually will have not button like this, but there will be a button called DEG or something similar. the calculators have two ways to measure angles. One is degrees, another is radians. And there's another one called GRAD. I really don't know what that is. That's for some engineers. It's very specific to engineers. We just have to know degrees and radians. Now, for these solving triangle problems, you only use degrees. So you have to make sure your calculator is in degree mode, or else all your calculation will be off. Okay. So what we're trying to do is we're trying to do 8 divided by sine of 32 degrees. So that's 15.097. Okay, 15.097. Let's put that. So 8 over sine 32. This is about 15.097. And then you have a over sine 58 degrees. This should be degrees. Sine 58 degrees equals to 15.097. Therefore, you multiply this to the other side and you get a equals to 15.097 times sine of 58 degrees. Okay, so let's do that. 15 points. Okay, back. So again, 15.097 times sine of 58 degrees. And that's 12.80. Let's just use 4 significant digits. So 12.80 is the value of A. 12.80. Okay, you can do the same thing for B. B over sine 90 is 15.097, so that B would be 15.097 times sine of 90 degrees. But guess what? Sine of 90 degrees is 1. How do I know? Well, I just know that. Let me just show you. Sine of 90 equals to 1. Okay? So sine 90 is just 1. 1 times 15.097 is 15.097. Okay, well, the same thing as like 15.10, right? It's very close to 0.9 is the same thing as very close to 10, right? So that's what we see. So when you these type of problems are called solving triangles. You're given some lengths and angles of a triangle, and you have to figure out all the unknown angles, unknown sides. And we found that the angle A is 58. The length A is 12.80, and length B is 15.80. And by the way, because the original length was given as centimeters, you better put the centimeters as your unit, or it's not 100% correct. Okay, hopefully that looked easy. Let's do another one. Okay, another one of these one length problem. You have one length, two angles, and so the third angle is what? So 32 degrees plus 47 degrees plus C would give you 180 degrees. Let's see, what's this? This is 79 degrees plus C is 180. So if you subtract 79, that's 101 degrees. So angle C is 101 degrees. Okay. And then we use the sine law because we just have one length. One side is known. So we say A over A, which is unknown, A over sine of A, which is 32 degrees, is equal to B, which is unknown, of sine of B, but that's 47 degrees, equals to C, which is 21, and that's equal to sine, 21 should be divided by sine of C, and I know that C is 101. So I put 101 degrees. And of these three things, only this can be actually calculated. These I don't know what they are, so I'll have to exactly calculate this. Let's use our calculator. 21 over sine 101. So 21 divided by sine 101, 21.39. 21.39. Okay, good. So this 21.39 is this value. This is about 21.39. Okay, and then a over sine 32 is 32 degrees is 21.39. So that means if I multiply sine 32 both sides, I get 21.39 times sine 32 degrees. Let's try that out. Move it over here. 21.39 times sine of 32 degrees, 11.33. So that's 11.33. So that's one of the answers. Okay, now we just have to figure out what b is. b over sine 47 degrees is equal to 21.39. Multiply and you get b equals to 21.39 times sine 47 degrees. Sine 47. Okay, so let's try that again. Yeah. So, read that. So 21.39 times sine of 47 degrees. That's 15.64. Oops. Okay, 15.64. Done. Okay, so these are the answers. Let's move on. Another of the same thing. Okay, so this time a plus 68 plus 29 is 180. If you add these two, that's 97. So if you subtract 97, that would be 83 degrees. Okay. Now you do, well, the naming convention is this is A, this side is opposite of A, and this side will be C. You have to always follow the naming convention, or else you will mess up all the answers, okay? So A, which is unknown, divided by sine of A, but A is 83 degrees, so you put that there, equals to B, which is known, 15.2, divided by angle B, sine of 68 degrees, and then C, unknown, divided by sine of 29 degrees. Okay, this is the part that we do know, so let's use the calculator to calculate it. So we have 15.2 divided by sine of 68. 16.39. Okay, so we know that this value here, this is 16.39. Okay. Therefore, we have A over sine 83 degrees equals to 16.39, multiplying by sine 83 degrees both sides. We have A equals to 16.39 times sine of 83 degrees. Okay, good. So what do we have? We have 16.39 multiplied by, oh, I thought I deleted everything. Let's do that again. 16.39 times sine of 83 degrees. And 16.267, that rounds up to 16.27. So that's 16.27. Okay, c over sine 29 degrees equals to 16.39. Therefore, c is 16.39 times sine 29 degrees. So let's try that. Delete. And then we have sine of 29 degrees is 7.946. This would be 7.946. Okay, so another problem done. Next. So this is the first time we have a question where you have two or more sides. So let's write down the cosine law so that we don't have trouble with that. So let's see. C squared equals to a squared plus b squared. Think Pythagorean theorem first. And then there's a minus 2ab. You have to remember minus 2ab. And then, because it's a cosine law, of course there should be a cosine. And whatever length you're given, that's the angle that you use. That's the cosine law. And then you should permute the a, b, and c. So c goes to a goes to b goes to c, a goes to b goes to c goes to a. Use this permutation, then this is what you have. And unfortunately, because for us the angle 26 is given, we need the one that gives you that uses cosine b. So unfortunately, we have to rotate this one more time. So b squared equals to a squared plus b goes to c, right? C squared plus a squared minus 2ca cosine b. Okay, so this is the one that I need to use. So let's try this. So unknown b squared is c squared, which is, what is c? By naming convention, opposite of c is right here. So that's your c. Opposite of a is this, so that's your a. Okay, so c squared is 18 squared plus 26 squared minus twice of 26 times 18 times 26 times cosine of 26 degrees. Okay, so that's what we need to calculate. So let's do that one by one. Okay, I think this calculator is slightly easier to use than your hand calculator, scientific calculator. So you'll have to write all these individually. Okay, so 18 squared, and then plus 26 squared minus 2 times 18 times 26 times cosine of 26 degrees. Okay, that's 158.72. Let's write down the 158.72. And finally, b would be the square root. Because b squared is 158.72, we take the square root both sides. We have this. I told you over and over again, when you take the square away, it should be plus or minus, but here it doesn't apply because b is a length, so you only take the positive. So what is that? Square root of 158.72. Square root of 158.72 is 12.598. Well, if you start from 8, carry over, that gives you this as 10, so that gives you 1. So if you round up, you end up with 12.60. So this will be 12.60. Okay, so that's how you figure out your length b. But so far so good. But here you actually need you actually need another formula. I promised as if I'm only going to use Sine Law and Cosine Law, and then a plus b plus c equals 180. But it's not a new formula. It's still the Cosine Law, but you have to change it a little bit. See, the thing is, you need to know either angle A or angle C, right? So to get any one of them, you have to take this and solve for the cosine. So let me tell you what I mean. So what you do is you have this modified cosine law. Cosine law to find an angle. It's the same thing, but you just have to solve for a different variable. So you take this, you have c squared equals to a squared plus b squared minus 2ab cosine c, and you want to know this angle capital C. That's the one that we don't know. So in order to do that, what you do is you first, well, you can move the entire thing this way and subtract c squared this way. That makes this positive, so it's easier to work with. So this becomes 2ab cosine c equals to a squared plus b squared minus c squared. And then you want to get rid of this 2ab all at once by just dividing by 2ab. So all of these just will be divided here, so they go away, and then you have cosine c. And then finally what you do is you apply the cosine inverse both sides. And cosine inverse is an inverse function of cosine, so they just cancel each other. You know, inverse function, when you compose with a function, they cancel. So you have this single formula, which again, if you want the other angles, you can apply this permutation and get the formulas for B and A and all that. But this is the formula that you want to use. Now, if you think trying to remember this is too challenging, or getting this is too challenging, here's another way to go about it. You could, in principle, just calculate this as it is with the cosine c unknown, and then you can solve that equation. But you know, I would suggest just try to go from here to there several times. Just repeat this procedure like 4 times, and you'll get it. It'll be really easy. So you just do this, and then when the exam comes, trying to go from here to there, it would be like a snap. It would be really easy. So just invest your time a little bit to go from here to there, like maybe 4 times, and then you'll be set to go. Okay. So we're just going to use this. So let's see, what do we have? We have C as cosine inverse of A is 26 squared. B squared is actually 158.72. Minus C squared. C is 18 squared. And divided by twice of 26 times 12.60. And you take this entire thing and take the cosine inverse. Okay, so that's going to give me the angle C. So let's try to put that on the calculator. It's quite ugly. Let's see. You know, when you have fraction, you want to put parentheses on the entire top. So I'm going to start with the parentheses. 26 squared plus 15872 minus 18 squared, and that is divided by another parenthesis, 2 times 26 times 12.60. Okay, and that's equal to 24.76. Well, something's not right. Oh, sorry, I forgot a decimal here, right? Yeah, sorry. I hope you can put that dot there. Ah, I messed up. Okay, sorry. Let me do that again. Okay, 26 squared plus 158.72. That was the one. The dot was the one that I forgot. Minus 18 squared. And then finally divided by 2 times 26 times 12.6. Okay, and the answer is 0.77948. Is this thing. Okay, let me just copy it over here. This thing. And you're taking the cosine inverse of that. Okay, so we're taking cosine inverse of that. And again, if we use the cosine inverse, well, AC and then cosine inverse. Another name for cosine inverse is arc cosine, and then I'm going to paste. No, I can't do that. Right, so 0.77948. And the answer is 38.79 degrees. Okay, so that's 38.79 degrees. That was hard. Okay. And then you have, since you have B, the only unknown angle now is A, right? But A is what? A is 180 minus 26 minus 38.79 degrees, which is, let's see, 565, 115, right? 115. So this would be 115.21 degrees. Okay? So that's our answer. So we have this angle, this angle. Since the triangle was given as two sides and one angle, the answer will be one side and two angles. Alright, let's see. There are two triangles satisfying the following condition: A, B, and angle B. Find the length C for both triangles. Okay. So in this case, you have two sides. So which one do we use? We use the cosine law, right? And we have to use the one that has the B there. So I'm not going to be writing this all the time. I'll just quote this one: B squared equals to C squared plus A squared minus 2CA cosine A. So let's write that down. B squared equals to A squared plus C squared minus 2AC cosine B. Okay, I'm using this cosine law because that one has the angle B. Whatever the angle you're given, you can use that. Okay. So now let's see. We don't know length C. That's the question. Find the length of the C for both triangles. Okay. So apparently there are two answers for this. So let's find out why. Okay. So let's see. B squared. B is 9, so you have 9 squared. A is 12. It's 12 squared plus C squared minus 2 times 12 C times cosine of 25 degrees. Okay. And then this is, sometimes hand is faster than the calculator. 12 squared is 144. Is 24. C times cosine 25 degrees. And of course I can't figure out 24 times cosine 25 without a calculator, so let's try that. Let's move it over here. 24 times cosine 25. Oops. 24 times cosine 25. Okay, 21.75. Alright, so this is what you get: C squared minus 21.75 C, and then plus 144, and if you move this to the other side, subtracting 81 gives you 63 equal to 0. And then you need to figure out this value of C, and the reason that you get two values of C is, of course, this is a quadratic equation, right? So if you solve this, you're going to get two values of C. And the way you would solve this would be use x equals to negative b, but there's this, think of C as x, okay? C is the unknown x, and this is b, then 1, and then 63 is the C for the quadratic formula, so it's negative of negative 21.75 plus minus square root negative 21.75 squared minus 4 times 1 times 63 all over twice of 1. Okay, so I have to put that in the calculator. A lot of these triangle solving questions, they're not hard. You just have to know which formula to use, but then it's time consuming because of the calculator. You just have to use the calculator. Okay. So let's do this thing inside first. So what is 21.75 squared? Oh, 21.75 squared. Okay. And I didn't put the minus there because minus just goes away because you squared it. And then minus 4 times 1 times 63. Times 1 doesn't do anything. Right? So that's 221.625, right? And then, so 221. So let's copy that down. Put over here. Okay. So here's our situation right now. We have negative is positive. It's 21.75 plus or minus square root of 221.0625 divided by 2. That's what you have to do. Let's continue on. So what is this thing? 221.0625 square root. Well, square root is the same as 1/2 power, so I'm going to put power to 0.5. The same as the square root. Sometimes I forget to put the square root before. I just put raised to the power of 0.5. It's very handy. So that's 14.87 basically. So let's write that down. So 14.87. This thing is same as 14.87. So 21.75 plus or minus 14.87. So you have two possibilities. One, you could add, in which case 7 plus 5 is 2. There's a carryover. 7 plus 8 is 5, but there's a carryover. There's a 1. 1 plus 4 plus 1, that's 6. And then 1 plus 2 is 3 divided by 2. And then another one is subtract 5 minus 7, that's 8. And then another 8. And then 4 minus 1 is 3, but because you had because of the carryover, this must be 2. And no, just a minute. I'm doing the opposite. Okay. Just a minute. Yeah, 1. Okay, this would be 6.88. Okay. All right. You could do this in a calculator, but sometimes just writing it is faster, or mental math is faster. 36 divided by 2 is 18. 6 divided by 2 is 3. 2 divided by 2 is 1. Or 6 divided by 2 is 3. 8 divided by 2 is 4. Okay, so those are the two values of C. Okay? So it wasn't too bad. I hope you feel like it wasn't too bad. Okay, solve the triangle whose sides are A, B, C. Well, it's all given 4, 5, 7. All right, so you have 4, and then 5, and then this is 7. And because this is A, this angle should be A. This is B, So this angle should be B, and this is C. Okay, this will be C. Alright, so this is a case when we have to find the angle from the lengths, and because we have to find the angle, we have to use the cosine law. We have to use the cosine law because we're given 3 lengths. More than two or three, we use cosine. But the version of the cosine we use is not the usual cosine, but the one that gives you the angle. So remember this: C equals to cosine inverse of a squared plus b squared minus c squared over 2ab. So that's the one we'll have to use, okay? So this will be cosine inverse of 4 squared is 16, b is 5, so 5 squared is 25, and then 7 squared is 49, divided by twice of 4 times 5. Okay, I just don't use the calculator. Let's see, what is this? That's 41 minus 49, that's negative 8, and that's so that's negative 8 over 40, but that's negative 0.2. So you're doing cosine inverse of negative 0.2. Alright, see, that's actually easier than punching things in the calculator. Now, cosine inverse of negative 0.2, that I don't know, so I'm going to use this. Arc cosine of negative 0.2 is 101.53 degrees, okay? Or 101.5 degrees. 101.5 degrees, okay? Now let's do the same thing for B. Or if I rotate this around, so if I do the A, B, C trick, C goes to A, so angle A would be cosine inverse of B squared plus C squared minus A squared over 2AB. No, 2BC, sorry. 2BC. Okay. And that's good enough. I just need 2 angles, and the rest of them will be 180 minus the sum of the other 2 angles. So I just need to use this. Cosine inverse of B squared is 5 squared, which is 25. C squared is 7 squared, 49. Minus 4 squared, that's 16, over twice of 5 times 7. Okay, so let's see, cosine inverse. 25 minus 16 is 9, 9 plus 49 will be 58. And 2 times 5 is 10, times 7, that's 70. Okay, so that's not too bad. Let's punch that into the calculator. Let's see, cosine inverse of 58 divided by 70, and that's 34.05 degrees. If you round it to the nearest number, it's 34.05 degrees, okay? And therefore B is going to be 180 degrees minus A minus C, and the sum of these two is 180 degrees minus 135.55. So what's that? That's going to be 80 minus 35. That's 44.45 degrees. Okay, so these are the 3 angles. So we have found the remaining 3 angles, and since we know all the 3 angles and all the 3 sides, we have solved the triangle. Okay, another one, A, B, and then C. Well, I think at this point that's easy, right? You have 2 sides, you need the cosine law. C squared equals to A squared plus B squared minus 2AB cosine C. And this is the one that I would like to use because the angle C is given. So I have to use a cosine law because we have 2 lengths, 2 sides, and then cosine C, the 70 will go here. So let's try to figure this out. C squared would be a squared, which is 25. b is 7, so 7 squared, that's 49. Minus 2 times 5 times 7. Cosine of 70 degrees. 5 plus 9 is 4. 2 plus 4 and carry over, that's 7. 74 minus 70 times cosine 70 degrees. That's what we need to do. So let's apply the calculator. 74 minus 70 times cosine of 74 minus 70 times cosine of 70. That's 50.06. Okay. 50.06. And therefore C must be square root of that. You don't have to put plus minus because this is the length. And what's that? That is 7 point something. Square root of 50.06. 7.075. Alright. And then, so we have all the three lengths. We have one angle, so we need to find two other angles. And therefore, I have to use the formula for finding angles. Let's look at the previous slides to figure out what that was. A is this one, so let's use that. A is cosine inverse of b squared plus c squared minus a squared over 2bc. And in our case, cosine inverse of b squared is 7 squared is 49. C squared is 50.06 minus a squared, a is 25, divided by twice of 7 times 7.075. So let's try this. Okay. So what's that? I want to do cosine inverse. Let's see. Cosine inverse of the top, in parenthesis, 49 plus 50.06 minus 25 divided by another denominator, 2 times 7 times 7.075 parenthesis, and then parenthesis, and you get 41.61. That's the nearest 4 significant digits. 41.61. Okay. 41.61. 41.61. Okay, good. So we have that, and then finally, to get the angle B, B would be 180 minus C minus A. 180 minus 70 is 110, so 110 minus A, which is 41.61. What is that? 42, 32, 68.39 degrees. Okay, and we found the length, another angle, another angle. We've solved it. Alright. So we have now degrees and radians. Okay, and these are pretty easy. All you need to know are these two formulas. To go from degree to radians, you multiply by pi over 180 degrees. Okay, and then to go from radians to degrees, you take the reciprocal. You multiply 180 over pi. what this means is this is equivalent to saying the following. 180 degrees, if you want to take the 180 degrees and change to radians, you would multiply by pi over 180 degrees. And notice how the degree cancels, right? Not only 180 cancels, but the unit, this degree cancels. So when you remember these formulas, it's important that you put these small circles because that actually helps you from getting confused which one's which, okay? To get rid of the degree so that you end up with radians, then you want to have the degree in the bottom. So 180 actually is equal to pi. And that's what this formula is saying. So basically 180 degrees becomes pi radians. Radians is just another way of measuring angles, just like everywhere in the world uses this centimeters to measure length, and only in America we use this weird unit called inches that nobody else in the world understands. Maybe UK does understand, I don't know. But anyways, for measuring angles, you have two things. One is the radians, which actually becomes really important in calculus. After all, this course is called Precalculus, so we have to also learn something that might be getting important in the calculus world, right? So radians is important in calculus, whereas degrees is useful for everything else. I mean, who measures angles in radians? Nobody, except when you do calculation in calculus. Well, you're going to learn that later. But the unit correspondence is that 180 degrees is same thing as pi radians. This comes from the fact that the radians is using the circumference of the arc length of the unit circle to measure angles. So if you have a unit circle, which means it's the radius 1, since radius is 1, actually the diameter is 2. It looks like a Pac-Man, but I'm really drawing a circle with this line, and this is number 1, okay? So if the radius is 1, what's the diameter? Diameter is 2, right? And because the circumference is diameter times pi, the circumference is 2 pi. So what this is saying is that 360 degrees is the same thing as 2 pi. And therefore, if you divide both sides by 2, you end up with 180 degrees equals to pi. Okay. Hopefully you understood this. If not, you probably want to watch other YouTube videos about radians and degrees. Then it will all make sense, okay? Alright, so these are just the formulas. Now let's actually use them. Here, 4 pi over 5, if there's no unit, that means it's the radians. Radians is also strange that it actually has no unit. It's just a number, and when a number is used to measure an angle, it's called a radians. So you have 4 pi over 5. Since this is a radians, I need to change it to degrees. I use this formula, okay? I have to multiply by 180 over pi, so I multiply by 180 degrees over pi. And pi cancels, right? And then 180 divided by 5, I believe is 36. It's 4 times 36. And then 4 times 36 is 144. And it's beautiful because this degree, because there's a degree symbol, at the end of the day you end up with a degree symbol, so that's good. Oh, well, convert 144 into radians. I already know that what that is. This came from 4 pi over 5, so that's the answer. But let's pretend that we didn't know that. How do you go from 144 degrees to radians? Because you're going from degrees to radians, you use this formula, which is multiplied by pi over 180. And then that means degree cancels, and then you have 144 pi over 180. Well, let's see. I think top and bottom are both divisible by 9. I know that because 1 plus 4 is 9, and 18 is divisible by 9. So there's some rule that quickly tells you if it's divisible by 9. So this is 9 times 1, and 54, 9 times 16. So 9 times 16 is 144, and 18 divided by 9 is 2, so it's over 20. I see that top and bottom are both divisible by 4, so if I divide by 4, that's 4 pi, and then it's over 5. So that's the answer. Okay. find the reference angle. What's a reference angle? Well, we have to think about the unit circle. See, angles, when used for trigonometry, those are put on the unit circle. And the reference angle is the angle from, I guess it's easier to explain with an actual example. So think about something like 210 degrees. What's that? That's beyond 180 degrees, but it's before 270. All the angles are always measured from the positive x-axis. Mathematicians have these international standards, just like engineers have international standards. And the international standard is that when you put angles on the unit circle, you always start from the positive x-axis and you go counterclockwise. That's the international standard. Okay? And then if you go this much, that's 180 degrees, because that's an entire 180 degrees. And then you have to go a little bit more. See, if you're over here, that's 180 plus 90, so this would be 270, right? But 270 is beyond 210, so it probably stops somewhere here. So this is the angle that 210 degrees talk about. And what is the reference angle? The reference angle is the closest angle to the x-axis. That's what it means. So it's this angle here that's called the reference angle. In other words, closest angle to x-axis. So in this case, 210 is 180 plus 30, so the reference angle will be 30 degrees. Alright, so let's try to figure this out. I really have trouble with radians, but the rule is, if the question is given as radians, you have to answer in radians. But since I have so much trouble with radians, I'm going to first change this into degrees by multiplying by 180 degrees over pi. Pi cancels, and this is, 180 divided by 5 is 36. And if you multiply this, this would be 288 degrees. Okay, so what is 288 degrees? Well, if you put it on the circle, that's beyond 270, so here's 180 and then another 90 degrees, that gives you 270 degrees. This is 0, and then this is 90 degrees, and then this will be 180 degrees, and this will be 270 degrees, and you go beyond a little bit. So really the reference angle would be the angle to 360, right? If you go full circle, this would be 360. So you have to know how far you must go from 288 to 360 in order to get to the x-axis. So the reference angle would be ref angle would be 360 minus 288, which gives you 72 degrees. Okay? Now 72 degrees will have to be changed back to radians because the original question was in radians. So you have to multiply this by pi over 180 degrees. That's how you change back to radians. Degrees cancel. So you have 72 over 180 times pi. I know that top and bottom is divisible by 9. 9 times 8 is 72. And 9 times 20 is 180. And then yet again, 8 and 20, they're both divisible by 4, so it's 2 over 5 pi. Okay. You can write 2 over 5 pi, or you can also write 2 pi over 5. Either way would be good. Okay, so the answer to the first one would be 2 pi over 5, or just like 2 over 5 pi. Either way. Okay, now let's think about the second one. Negative 1324. Well, that's a huge angle. So what happens there is that if you start from here and you go negative, that means you go clockwise, and you go beyond 360, 360, 360, and at some point you reach some point. Okay. Now the thing is, any multiple of 360, if you add, it doesn't change the landing position. So in that case, we say the two angles. If two angles are apart by 360, it lands on the same place, right? If one angle is here and then you go around another 360 and then you come back to the same thing. So if two angles differ by 360, we say that they are coterminal angles. And the trick is here, I have this huge negative 1324. To make this simpler, you just keep adding 360 or subtract 360 until you get a small number, something that you can handle, right? So I'm just going to add 360 here. Let's see, what's that? That's 4. You're basically subtracting, right? So 4 minus here is 4, 2 minus 6 is 6. This will be 2, this will be 964. Okay, so you have 964. Add another 660, and that gives you 40604. Add another 360, and that gives you 4. Let's see, 0 minus 6 is 4. That's 244. Okay. All right. So and you can add another 360 because this is so negative. It's hard to figure out what that is. So I add 360. Then what's that? That's 4 minus 0 is 4. 4 minus 6 is 8. And alright. I shouldn't do this. Let's see. 360 divided by 244. That's what I should do. That's 6, 1, 116 degrees. Okay. So you have this 116 degrees, which is slightly after 90 degrees, right? So here's right here, which is 116 degrees, slightly after the 90 degrees. And we see that the closest x-axis is 180 degrees. So to get the closest angle to the x-axis, you need to subtract from 180. So the ref angle would be 180 minus 116, which is, let's see, 4 and then 64 degrees. So that's the reference angle. And because the original question was given in degrees, you should answer in degrees. That's all good.